let's get started. So today what we're going to be showing you how to do is creating this kind of data visualization look. This idea of projecting 2D stats on top of 3D objects in a 3D space. And these stats will kind of track the objects. We can move the camera around and it will kind of move with them. And then in this case, we can hide them after a few seconds as we speed up time. So we'll rebuild this. We're also going to be doing this in this kind of more abstract space. We're not going to be doing it in a planet surface space, but we're going to do it in an open space with these kind of simple colors. So it should look pretty nice. Okay, so let's get started. I'm going to go File, New. And the first thing I'm going to do is get out of this space. We don't want to kind of be in this real world space. We're going to go into this more abstract color space. And so I'm just going to go to the browser here. I'm going to right click here and create a new open space and double click on that open space. And that puts us in this abstract space. Another thing I'm going to do is I'm going to turn off the exposure layer. Exposure layer, what it does is it takes the colors and it kind of adapts them to then properly be able to render onto your display, onto your monitor. And in so doing so, it shifts kind of the brightnesses of all the values of the colors in the space to kind of make it so it can render correctly. And so that tends to gray out whites and a bunch of other things. So by removing it, we don't get automatic exposure. That means if we go up to a really bright object, everything will kind of saturate out and be overly white and bright. But that's okay. By turning it off, we can then control for the colors a lot more tightly. So I'm turning off the exposure layer here, and then I'm going to set our haze color here to white, so we have a perfect white background. And then I'm going to create a reflecting surface for the ground. I'm going to create a mirror here for the ground, and I'm going to set this mirror's dimensions. I'm going to remove its rigid, or actually, let's keep its rigid body, but I'm going to set the rigid body to not movable. And I'm going to extend out the dimensions so it goes all the way into the horizon. So I'm going to set these to be 1,000. Actually, let's make it a 5,000 by 5,000. So now we have a nice reflecting ground. So if I draw something now on the ground, you'll see that it has a reflection. And I'm also going to hide the grid. Actually, we can keep the grid for now. I'm going to lock the ground as well. So I'm going to select it, hit Control L, so I can't select it anymore by mistake. So we now have a nice kind of a scene that's just a simple reflection scene. Hide the grid here. So our goal today is going to be to, and I'm also going to actually hide the ambient light as well. Keep it simple here, the lighting. Let's see here, maybe we'll, yeah, it's kind of bright. We turn off this thing. Set ambient to false. Yeah, there we go. I just turned off the ambient light, so we're back to our kind of natural colors here that we can make super bright. So our goal in this today's demo is I want to take an object in the space like this cube here, and I want to augment it with some information. I want to kind of overlay a two-dimensional tag of information or a shape. And so we can imagine we'll start off with these simple shapes here. So let's say we have these these shapes, and we want to augment these with kind of this extra information. So let's go and build that extra information, that thing that we want to overlay, and then we'll work on how to connect the two together. So I'm going to create a new screen layer on the viewport here. Screen layer is a 2D layer that lives on top of lives two-dimensionally on the top. So now I can draw on the 2D screen. And now what I want to do is build, using shapes and text and whatever we want, imported objects. I want to just build our little overlapping overlay thing. So I'm going to use actually a ring. This will be our little like highlight ring that will highlight the object. And then I'm going to create a box here to create like a line for some text. I'm going to just move this a little bit in so it's nice and tight to that. And then I'm going to create some text. And I'm going to stick this text right on top of this. And I'm going to make this smaller here, this text shape, make the font smaller. Maybe I'll make this actually a little bit shorter, this. Because it's going to ultimately have a number on it, so the numbers don't get very long, so I'm going to just shorten it up. And I'm going to select all these things, I'm going to group them, so I'm going to hit Control E, that sticks it in a group. And so one of the things to understand, when we create a group, it automatically kind of centers it makes it so that all the objects are kind of centered with respect to that group. But now the group, this object is going to get placed on top of objects in the 3D space. We're going to write some script to kind of automatically place this on the objects in the 3D space. And so therefore it's going to place the center of our group. This is the object that we're going to be setting the group. And so we want to make sure that it actually is centered such that the center of this is actually where our circle is, because that's going to point out our object. So I'm going to go ahead and double click on the group, and I'm just going to move this over here until it's kind of centered on our circle. And the other way to do it is just stick the group somewhere and just center out our tube entities transform, since it's a child of this. Now it'll be exactly centered on that. And if I hide the helpers, I think everything else lines up pretty well. So I'm going to go back up a level here. And so now wherever this gets placed, we're going to place this, we're going to project its position in 2D space, and we're going to stick it on the 3D object. Well, it'll create this effect here. This is going to point out the location of the object. So our goal now is to connect, we're going to basically, in script, we're going to be making copies of this object and placing it on top of the 3D object, wherever it happens to be in 3D space. So how do we do that? Well, there's going to be two parts to this. Part number one is going to be iterating over all the objects in the 3D space, finding all those objects, making copies of each one of these objects, and then setting up these objects to track the object in 3D space so that they kind of track it correctly. So let's start by writing our script that kind of finds all of the objects in the space. And so to do that, I'm going to go back into the space here. By clicking here, we're back to editing this. I can't edit this now. I can't grab it because I haven't clicked on this layer here. So I'm back in the space layer here. And then inside the open space, I'm going to right-click and create a new global script. And this is going to be our stats manager. And I'm going to double click on this to edit it. This is the default code that's always created. I'm going to just delete this out here. And we're basically going to define in here a function that lives in this global script called analyze. And when we call this, this will show will make all these kind of text shapes appear. These stat objects appear on top of the objects. And then maybe we can have a companion function called hide analysis or something, or hide stats. And this will hide all the statistics, all these overlapping things. But we'll do that later. So the first thing we want to do is gather all the objects in the space. And so we can do that by saying self.getParent. That returns we're currently inside this library, so the parent returns the space object itself. And then we can say get child nodes. And let's store those inside a table. Now what I'm going to do is I'm going to iterate over this table, and for every object we find, I'm going to make a copy of this object and connect this object in the 3D space with this object. So let's go ahead and do that. So for I is equal to 1, 2, the total number of elements in our table, do. So for each item, so this is going to be our node. I'm just going to pull the item out of the table just to make it a little bit more legible. And we're going to filter for some objects. So there might be some objects in the space that we don't want to apply this to. For instance, the ground plane. The ground plane has a physics, is physical in terms of things can collide with it, but it's not movable. So we can filter based on that. So first of all, we only are interested if the node has a rigid body. So if the node has a rigid body and the node's rigid body is movable, then and these are the objects, this is our filter basically, so only these objects will have our overlapping stats added for them. So if they are, we need to now access this object here and make a copy of it. So I'm going to click on I'm going to go back to the screen space here and grab this object here. And I'm going to, let's rename this to our stats, our object stats. And I'm going to take this, I'm just going to drag and drop this into here so we can access it from our script. And we don't need to access it within the script, we just need to access it outside the script. So what we're going to do is we're going to make a copy of this. So I'm going to say clone as copy, store a variable called copy, make this local so it can only live within this context. And then I'm going to call a function this copy. Now we haven't written this function yet, but we will. We're going to go and write this inside the object. But we're going to basically say set our target node. And I'm going to set it to that node object. So basically what I'm doing is for each one of these objects, I'm creating a copy of this, and then I'm going to be calling a function on this, which we're going to be adding in a second, that says you are going to target the respective object that I'm copying you for. So it might be this red one, it might be this object. So we're going to be storing that object that it's going to be tracking inside the object itself. So that's it for now for this function. So when we call this analyze function, it's going to loop over all the objects in the space, and it's going to create a copy of this object, this stat object for them, and it's going to call a function on that object that we're going to be adding right now called setTargetNode, and it's going to store that object inside that node. And consequently, we can also store the target object inside the node, and this will be useful later when we do hide stats. So in our node, I'm going to set node.stats object is equal to copy. So again, I'm just going to be storing this text shape, this object here, inside the object itself, so we can access it later on. So we can kind of go back and forth. From here, I can access its tracking object, and from here, I can access its stats object. And the other thing I want to do is create an onInit function. This is a function that gets called when we hit play, and I'm just going to invoke this function right away. I'm just going to call analyze, so it'll immediately call this function and place these things on top of these. So if we hit play now, not much is going to happen. It just made a bunch of copies of this, and it's throwing an error because we haven't implemented this function yet. So let's go and implement this function. So it's going to live on this object itself. So we're going to go back to the screen space layer here, and we're going to click on this object, and then I'm just going to add some script to this object. So I'm going to go and add object script, and I'm going to double click on the object script, and in this object here, we're going to implement that setTargetNode function. I'm going to say function node setTargetNode, and we're going to be passing in the node. This is the node in the 3D space, and for this, we're just going to store it inside our table. So we're going to create a little local variable. This is per instance, so each instance that we make each copy is going to have this per copy. We're going to store our target node inside, and we're going to initialize it to nothing initially, and then here we're going to set that. Target node is equal to the node we pass in. So now we have a nice little function that we can call in this object, that when we call setTargetNode, we're storing that 3D object inside this object so we can access it from inside here. So let's see what happens when we hit play. So not much happens, but if we look here in the screen space, I'm going to make it so I can grab these objects here. On the screen space, we'll see that there will be copies of these objects. So we've now made one copy per one of these things, and they're all overlapping each other. So now our next goal is to have that object track wherever this is in 3D space. And this is really the crux of this example. So I'm going to go back into the script for the node itself, this setTargetNode. And we're going to implement a function, the onTick function. So this is code that's called everyFrame. So every frame that we render a frame, we're going to update our position to match the location of our target node. So the first thing we're going to want to do is just verify that our target node exists, because there could be cases where that target node is destroyed, and so this will ensure that if it ever gets removed from the space, this won't throw an error. So we just verify that our object actually exists. If not, we don't do anything. So if it exists, we want to take that object's 3D position in space and figure out a 2D position that we can kind of stick our position, place our object on. So for that, we're going to implement a little utility function here called project2screen. And this is going to take in a 3D world position in 3D space. So our goal is to convert the coordinates in 3D space of an object to two-dimensional coordinates on our 2D space, and then set our position to match those coordinates. So how do we do that? Well, the first thing we're going to have to do is we're going to have to perform a projection of the object in the 3D space. So I'm going to go back into our 3D space, and I'm going to grab the default camera here and drag this into our project screen function. So that's the camera that we're looking out of in this case. And the camera has an object on it, a function called get view projection matrix. And if we hit F1 on this, we can see that this is a function that lives inside the view object. So the camera, if we go to the camera object, it derives from perspective view, which derives from view, and it contains this function called get the view projection matrix. So to understand what the view projection matrix is, we have to understand what a camera frustum is. So I'm going to just open Paint here, and I'll draw out a little picture here. So imagine that this is our 3D space, and we're looking at a camera's frustum here. So this represents what our camera can see. So our camera's eye lives right here, and this is the environment that we're looking at. So like right now, you can imagine everything I'm looking at in this space is inside this, what's referred to as this frustum. So our objects that we drew in the space, in this case, we drew 3 objects, they would be somewhere in the middle of this space here. What we want to do basically is right now we're trying to figure out how to project a 3-dimensional object onto our 2D plane. So this is our screen right here, right? This is what we're looking at on our screen. Our 2-dimensional screen in front of us is actually this part of the camera. What our view projection matrix is a transform matrix that's going to transform vertices, positions in 3D space, onto a 2-dimensional plane. So it essentially will take these 3D positions and project them onto our plane here. So you can imagine that this will appear as a 2-dimensional object when after projected on our plane here. And actually, this is actually done with perspective, so it wouldn't be straight. They would be kind of along the projection map. So the resultant is 3-dimensional objects that are projected onto a 2D screen. So we're going to write a formula here that literally takes these and projects them onto this 2D plane here. So back to our 3D space here. Let's take a look at what's going on here. So we're going to go back to our script here, our screen space here. We're going to edit this code here. And so back here we were writing this project to screen. And so we're getting that view projection matrix. What we're going to do is we're going to take the world pass. This is the position. This is going to be a 3D position of an object in 3D space, and we're going to project that onto our 2D screen by doing this. And we're going to store that in a coordinate. Projected pass. Our projected 2D position will be that. So again, we're taking that 3D position and we're projecting it onto, using the view projection matrix of the camera, and we're projecting it onto our screen. The next thing we're going to do is, so this now, we have to understand what the coordinates of this are. So if we look at our coordinates of this, what it's going to return is going to be a value that's between -1 and 1 for the x-axis, -1 and 1 for the y-axis. This is going to be a vector 3 that basically stores a value that goes from -1. So -1 will be the left side of my screen, and +1 is going to be the right side of the screen, and 0 is going to be the center. So it's going to be from -1 on the x-axis to +1 on the x-axis, -1 on the y-axis, so which is the bottom of the screen, to +1 on the top, and the same for the z-axis. It's going to be it's going to go from -1 to 1. It's been projected into our projection frame. So basically, what we get back is a coordinate that's in 2 dimensions, that where the value will be from -1 to 1 from the x, y, and z. But our coordinate, if we go and look at our screen space here, and we look at and we just draw an object on our screen space, you'll see that its position is actually in pixels here. So you'll see that 0, 0 is the center. If I zero out the center of this on the screen, I'm going to hide the 0, 0 in our screen space is the middle of the screen, and then if I put it all the way to the left, you'll see that its coordinates are, this is actually half my screen resolution here. And so we have to basically map -1 to 1 to -half our screen resolution to +half our screen resolution. And so to do that, we're just going to we're going to have to pull out our screen's resolution. So I'm going to go to the screen space, and we can get that from, if we click on the screen space, go to its camera, you'll see that it has the dimensions stored as a property of this screen view object. So I'm just going to drag this inside here, and I'm going to pull its dimensions out. And what we actually want is we want the half dimensions. So we want to take this and multiply this by 0.5, because what we want to go is from -half dimensions to +half dimensions. So now we're going to take our projected 2-dimensional position, dot x, what goes from -1 to 1 along the x-axis. We're going to multiply that by our half dimensions, dot x. So that will now go from half of our screen resolution to +half our screen resolution. And so that's going to be, we can store that under our v.x. We're going to say v, actually we're going to return this as a vector 3. And we're going to do the same thing for the y-axis. And for z, we don't actually care for now, so we're going to just return 0, because on the 2-dimensional plane, the z really doesn't have much bearing. It doesn't really have a significance there, but we still need to produce a 3-dimensional vector, so we'll set the z to 0. Okay, so we're returning a vector that is our projected value, that our two-dimensional value that's been massaged into our screen, our frame, into the world coordinates of our screen, which is in pixels here, by doing this basically. And that's going to return our three-dimensional, our object's position, but projected into our 2D plane. So what we need to just do now is set the position of our self to match that location. So we're going to set our world position to be our project to screen, our target nodes, get world position. So we're taking that 3D position in 3D space, we're projecting it into our 2D space, and then setting our position to be that position there on tick. So this is happening every frame. So if this all makes sense, let's see what happens when we hit play. There we go. So now if I move the camera around, you'll see, since it's on tick, it's happening every frame. And those objects, no matter where I position them, the two-dimensional kind of companion object is following them in 3D space. So we have this kind of nifty way now of kind of moving a two-dimensional thing on top of our. So you can imagine this could be like a target reticule. There's all sorts of cases where you want kind of to be able to do this. So the next thing we want to do is we want to kind of on play, maybe wait a little bit of time and then show this analysis, so to speak. So instead of right now, we're not setting the text, for instance. So let's set the text to something a little bit more interesting. So when we say set our target node inside here, we can actually set our text. And we can do that by searching our self here. So I'm going to click on this. And our text entity, we just need to get our text entity and our self. And then we can set the text value of it. And we can set it to the name of the node, for instance. So I'm going to say self find node by name. I'm searching my children, and I'm going to find text entity. And then text entity has a function called get mesh model, which has a function called get shape, which gets us to our text, and I'll show you what this is. I'm going to set this to the name of the node. So what that is basically doing is it's saying, okay, get the text entity, which is this object here. Then I'm saying get the mesh model, get the shape, and then I'm setting the text property to whatever I want, which in this case is going to be the name of the node, the target node that we're setting. So when you hit play, now each one of these things, it's showing the name of the object as part of its as that text. So instead of doing that, we could set it to, instead of setting it to the name here, we could on every frame update it to be some statistic, some value. So I think in the demo I was using the object's speed. And so we set it to the text equal to our target nodes self get target nodes get rigid body get the linear velocity and the length of that, which is our speed. Then we have to convert that to a string, so I'm going to say toString. So now it will be set to the object's linear velocity. Get target node. Whoops. Back into the script there for the object. There's an error in there. Get target node. Oh, self.target node, sorry. .target node, get rigid body. Okay, so now since they have no speed, it's 0. As I move them, you can see that now it's showing their kind of velocity as I move them. Let's round this. It's a little bit kind of it's a little bit too long, so I'm going to go back into our script here. And there's actually a little utility function. If you say require, it brings in this library called util, and the util library has a round function that we can call here. So I'm going to round this number here. So I'm going to say round this to the nearest 2 decimal places. That's what that's going to do. So now it shortens them all out. That's a little bit nicer looking. So that's neat. So let's see what happens if we start to make more copies of objects in this space here. Oh, let me delete this object. We don't want that anymore. So let's make some more copies. Hit play. Not too bad. Let's move some of these objects around here. Bump into each other. But I think it would be nicer if this happens kind of if we can invoke this and analyze. Right now we're doing it every single time we hit play immediately. Let's have it wait a little bit of time, because then what we can do is do something interesting in the space, and then we'll like freeze frame that, analyze that, and then we'll kind of resume where we left off. So to achieve this, I'm going to go back into the script here, And instead of calling analyze right away, we're just going to call analyze after a little bit of time. So I'm just going to, on a init, I'm going to create a timer, animator. Get the animator, create a timer on our self, because this is this function lives on our self. We're going to just have it call analyze, and we'll have it wait. We'll have it wait a certain amount of time. We'll have it wait 2 seconds. So instead of getting called right away, it's going to wait 2 seconds and then call analyze. So hit play, we make it do something, and then after 2 seconds they show up. And let's also have it maybe, instead of them just appearing immediately, let's have them scale up. So they kind of blip upwards. So they don't just appear, they kind of pop out. So to do that, I'm going to go back into the code here for the object, for the individual overlay object. And when we call set target node, we're going to create a little animation for the object. So I'm going to say get animator. I'm going to create a scale key clip. I'm going to pass in our self into there. It's going to return a clip, and then we're going to animate. Well, first we're going to want to set our scale to our world scale to 0, 0, 0. So it's going to start as completely invisible, like scaled all the way to 0. And then we're going to animate to 1, 1, 1, which is just. So I'm going to add a key here, and we'll have it animate in like half a second, and we're going to animate to 1, 1, 1. So it's going to animate our scale from 0, 0, 0 to 1, 1, 1 when we set the target node. So let's see what happens after 2 seconds. Now they kind of have that little animation. Maybe I'll make that faster. Maybe it'll happen in a 1/10 of a second. That's kind of neat. Okay. So actually, and we can also mess around with, like, maybe we can do a different kind of interpolator. We say set key interpolator elastic ease in. So if you hit F1 on set key interpolator, you'll see here a list of all the interpolators that you can use. So now they'll bubble out. And it's so fast that you can't really see it, so I'm going to slow down the animation just a little bit. So now they have this kind of like almost physical look to them. Now another thing we want to do here in our analyze function is the more objects we have, if we're doing this all in one frame, again this could get a little slow. If we have like 1,000 objects, we're going to be doing this all in one frame. Let's separate out that logic to happen across frames. So it's going to actually happen across maybe a few frames. We'll have it do a certain, at some rate, we'll do one per every every 10 milliseconds we'll create one, or every 100 milliseconds we'll create one. So they'll kind of pop in all across a range of time. So to do that, instead of doing this all at once here, what we're going to do is we're going to actually store. So I'm back inside the stats manager object. I'm going to create a little table in here. This is our table of objects. Initialize that to nothing, and then we're going to gather all those objects inside this table. So I'm not going to define a local table anymore. On analyze, we're going to store all those inside our table here that lives inside here, so we can access this from another function. And I'm also going to create an element. This is a value that we're going to increment for each element, so we can kind of keep indexing the next object inside the table. So this will make more sense in a second. So I'm going to initialize this to 1 here. Then I'm going to create a timer that it's going to get repeatedly called on ourself on next item. And we're going to call this every, actually we do milliseconds, every 100 milliseconds. And I'm going to say comma true. It's going to repeatedly call this function every 100 milliseconds on next item. And so it'll be in there that we're going to get the next item out of the table and then create a copy. And then this function will get called again and so forth until we've gone through the entire table. So now I'm going to implement actually we'll do it after this function. Global script on next item. So this loop now is not going to be here. We're going to do it inside on next item. The inside of that loop, because this is now our loop. And we're going to take the node out of our out of our table objects, which is the table we created, and this is going to be the element. And that'll be our node. Again, we're going to do some filtering here, and then we're going to create the copy. And then we just got to remember to increment element by 1. So then the next time this gets called, it's going to get repeatedly called every 100 milliseconds. It will then index out the next object out of our table and keep working its way up. I'm going to declare this as local. And the other thing we have to do is stop our timer once we've reached the end of our table. So if our element is greater than or equal to our table objects, the count of the elements inside our table objects, then we're going to stop our timer. So get animator stop timer, and then our timer function, which is self.on next item. So that once it's reached the last item, this will stop the timer automatically. And actually, we can probably just do this here, and we want to make sure if it's greater than that, so we don't lose that last object. So when we call analyze now, it's going to, well, so when we hit play on init, it's going to wait 2 seconds. Then it's going to call this analyze function. Analyze is going to gather all the objects in the space and store it in this table that we can access from any function inside here, and also reset this value element. Then it's going to create a timer that's going to get called every 100 milliseconds, and it's going to call this function. This function is going to pull an item, the current item, out of our table, and it's going to do what we did before. It's going to make a copy of this like 2D object and set that target node on it. And then it's going to increment our element so that next time this function gets called, we get the next item out of the table. And then if that reaches the total number of items in the table, we stop the timer. So now they should bubble out, but with some delay. Table expected. Oops, this is not in a self. This is just lives directly inside our thing here. So I didn't have to say self for that. Let's see what happens. Oops. Create a timer, function expected. On next item. Oops, capitalization here. I did lowercase here. Okay, let's see what happens now. And there we go. So now they kind of pop out. Maybe we'll speed that up a little bit. Let's make it, instead of 100 milliseconds, let's do 30 milliseconds instead. Okay, that looks pretty neat. So now we can call this analyze function, and when we do, the objects it will kind of go and do that. Another fun thing that we might want to do is let's slow down time. So let's imagine this is all running in real time, and then when we do analyze, we're going to slow down time while we're showing the analysis. And then after a certain amount of time, we can then go and hide the stats. So we're going to fill out this function too. So to do that, I'm going to create a timer. I'm going to create an animation. To slow down time, I'm going to say get animator. I'm going to create a key clip. But this time, I'm going to pass in this case, a property we want to animate. It's going to be the open space. If I click on the open space and I view its properties, we want to animate its timeline's timescale property. So we're going to have it go slow down time like that. So we want to animate this timescale property. So to get that, I'm just going to do self get parent. That's our space. And I'm going to say get timeline. That's our timeline object. And I'm going to get our timescale property. So that returns our timescale property object, and that's what this animator wants when you create a key clip. It wants the property object. It doesn't want the value itself. Like if we were to say dot timescale, that's the value itself, which would be one in this case. We want to pass in the property object. It's going to be animating that property object, and that returns an object called a key clip. And then we're going to say add a key, and maybe 0.1 seconds and a tenth of a second. We want to animate it down to like a tenth. So we're going to go from timescale 1 all the way to like 0.1. So it's going to slow down time. And then we want it to wait. We also want to create a timer that's going to wait a certain amount of time. And then it's going to call hide stats. Self.on hide stats. Hide stats. And let's have it wait 5 seconds. So what's going to happen is, again, when analyze is called, it's going to slow down time right away, and then it will call on next item repeatedly, showing popping up all those things. And then after 5 seconds, we're going to call this hide stats function, which we're going to fill out right now. Hide stats is going to hide all those statistics. So to do that, we're going to loop over. We're going to do this all in one frame. I think that should be fine. We're going to loop over all of our items in our table. Equals 1 to the items in our objects table. And we're just going to say, well, we want to make sure it exists. So as always, I'm going to store this inside a node to make it a little bit more legible. And then I'm going to say if it exists, because it might have been removed out of the space, the object, we don't know. So that will test for that. If the object exists, then we're going to get out of that thing our stats objects. Remember, we stored that inside the object up here. So our stats objects, we're going to say fade out and orphan. So that will remove it out of the space. That's going to loop over all objects, and it's going to pull out that like overlay 2D object, and then orphan it when this hide stats function gets called, which is going to call it after 5 seconds. So we're going to hit play, they're going to appear, and then after 5 seconds they'll get removed. 2 seconds go by, they all appear. Now imagine that these things have some velocities in them, and after 5 seconds, an error is thrown. Stats object is not stored in node. Okay, and we stored in there stats object. So there must be an object that we are not, that we maybe filtered out here. That's right, we got to perform the same filter here as well. So all we have to do is say if it exists and it has a stats object. Because there's other objects in this table that we didn't end up creating a stats object for, so we got to make sure we only remove things that actually have it. So this will test for that. All right, let's see what happens when we play. So after 2 seconds, those appear. Let's have it. And then after 5 seconds, they get removed from the space. Okay, so now let's let me actually I'm going to go to this plain ground here. I'm going to fade out that mirror. It's a little bit too strong. Let's just fade it out just slightly. Make this alpha blended. Fade it out so it's a little less dominating that, so it's a little bit more clear what we're looking at here. And I'm going to turn on gravity for this space. I'm going to go to the open space. I'm going to set its physics gravity to negative 9.806. Or close enough to that. 806. Now things will kind of fall. Stats appear, slow down time, and then wait 2 seconds. Oh, and then the other thing we want to do is re-speed up time. So let's go back into our stats manager. After we call hide stats, we're also going to speed up time. So we're going to do basically the same thing we did here, but the inverse. I'm just going to copy this, place it in here, and in this case I'm going to go back to 1, time scale of 1, which is real time. So that'll happen after it stops. So hit play. After 2 seconds they all appear, the stats, and then time is going to speed back up after the stats disappear. So I'm going to delete this, and let's do something a little bit more interesting here. Instead of that, I'm going to create a toy, this breakable box, which is kind of cool. So when we hit play, we can smash this. It smashes into a bunch of pieces. And some of those objects are getting removed. So another test that we have to do here on next item is, just like we did exists here to verify that the object exists, we have to also verify that it exists here. And the reason why is that this breakable box removes objects out of the space. And so those objects were in our table initially, but then they got removed. So this is another test that we have to check for, is make sure the object exists. A lot of little things we have to do, unfortunately, because we have to handle the case where things are getting removed out of the space and dynamically and stuff, and so that's what this test's for. So now we're going to go back into our thing, hit play, smash this, and then we get the little stats that appear for all those objects. And then it disappears. So some of these objects are kind of orphaning, and the reason why is that the object that was behind that got removed out of the space. So to fix that, we're going to have to go into the objects. We're going to go back into our overlapping object here on our screen space where our script lives that does the tracking. And if the object exists, then we do this. If it doesn't exist, because the object was removed out of the space, let's just deactivate ourselves. So that'll just hide us from the space. So when our object that we're tracking gets removed out of the space, which it does because the breakable box removes all the little objects out of the space, we'll hide ourselves. And that's what that does. And the only other thing we have to do is if we go, we have to click on our text shape, and we have to go into this is our object stats, or our root node object. We have to go and detach from shared copies. Oh, actually, we're making full copies, so we don't have to worry about that. Never mind. Okay, so let's see if this works now. Oops. Go back to our space. I'm going to pick this up and throw it. And I think I was making shared full copies of it. So, oh right, we're pre-deactivating them because they don't exist. So we got to make sure. One other little thing we got to do here in the script here is it's actually setting active to false in the beginning, because before we set a target node, this is actually setting itself to active as false. We just got to make sure we set active to true if we do have a target node. Oops. Ah. Good play here. Smash it. Stats appear. They're being tracked. And then after 5 seconds, they disappear. So again, just to make that clear, there's a lot of little quirks here that we have to worry about. I'm going to go back to the screen space. I'm going to look at the code and the object stats here. So a couple little quirks that we had to worry about is, again, if the object stops existing, because every frame it's checking to see if it has its target node. If it does, it activates ourself. If it doesn't, we deactivate ourself, and that hides this object from the space. So we got to remember to activate ourself if it does exist, because in the beginning on tick, it won't have a target node yet, and so it's going to deactivate itself. So we have to just remember to set ourselves to active when we do that. So let's keep modifying the space here, make it look a little nicer. So I'm going to go back to this cube here. I'm going to modify its material, give it a little bit more pop, and give it some color. I'm going to go into its glass material. Let's see its color set to this, give it a little bit of color this way. But it's reflecting the scene, and so the scene is very white. So we can actually maybe reduce the specularity on that. So it's less specular. Maybe I'll make this a little bit redder by exaggerating its HDR intensity value here. That looks a little bit nicer. And another thing we could do is let's actually have an emitter emit this thing. So I'm going to create an emitter. So I can have this, I'm going to rotate this emitter to face the ground, and I'm going to have this thing emit this cube here. So I'm going to just pick this cube here. And I want to just have this emit just one object so we don't get overkill with the number of objects in the space. So I'm going to set total to emit to 1. And I'm going to, okay, so it's going to wait a second and it's going to emit one object here. Let's move this off to the side here. So after 1 second, it emits it, and then we show the stats on it. So let's, and I'm going to crank up its velocity, its physics velocity. So it really accelerates it into the ground here. So now we're starting to get that look from before, from the demo. I'm going to reduce that a little bit here. And maybe we want to speed up that's the time it takes for it to add them. So let me go back into the stats manager. I'm going to set this maybe every 10 milliseconds instead. That's pretty neat. And let's change the color of our text shape, of our overlay objects. I'm going to go back to the screen space. And these all use a default material, so we should just be able to go into that default material and affect it. So, oops. So I'm going to go into this default material. Let's change, instead of using the color from the material and the object, each object has a color. Let's just take it just from the material. And let's set the color to, I like the combination of this blue with the red, looks nice. Hit play. And let's go back to the scene here. And maybe we can, I want that to be a little deeper red. It's a little bit too faded, the red. Go back into this thing's material. Let's see, maybe less specularity. Actually, yeah, let's do no specularity then. Let's just do lights only. And let's make it self-illuminated. No, that's no good. Directional light is white. We can make this some other color. Not very visible. Ambient light. Yeah. It's out in the fog, so we're also seeing some fog here, the haze. Reduce that. Let's see what that looks like. Let's see if we can brighten this up here a little bit. Materials, specularity. Oh, let's turn off the Fresnel effect, the Fresnel effect. Let's, we can unlight it. No, we don't want that. Let's take it just from the material, and let's really exaggerate this, yeah. Let's see here. Still having that. Ambient light is 0. Intensity is right. Specularity, opacity. Oh, let's not do refraction. That's why. Refraction was turned on too. Let's turn off refraction. Let's make this a little less bright here so we get a little bit more. Yeah, the default box smash material, it has refraction turned on, so we had to turn that off. And let's see what else we can do here. Maybe we can make this I don't know, instead of red, some other color that would look nice here. But I like the contrast between that blue and the red. So let's do red for now, deep red. Okay, so stop, let's take a look at that. So now we kind of have that. That looks kind of nice. Maybe we want to scale. Another thing we might want to do is scale the size of this object based on maybe its velocity. So maybe when it first creates it, it sets its scale to a value that's proportional to its velocity. So instead of animating to 111 here for the scale that we animated out, let's actually measure the object's velocity at the time we create this and scale it so that it has some scale that's proportional to its velocity. So I'm going to just take our target node, self.target node, get its rigid body. I'm going to get its linear velocity. And I'm going to get its length. That's our speed. So that's our speed here. So we want to scale it based on the speed here. So I'm going to set its scale to be the speed. It's going to be way too much, so we're going to have to scale down this value. And also, we don't want it to go less than 1. So if speed is less than 1, then speed is equal to 1. So it doesn't scale to a tiny little point. The minimum will be this size, basically. But they can get bigger than this. And we're going to set this equal to speed instead of 1. We're going to set it to speed, speed, speed. So it'll be a value that's either 1 or some bigger scale than that. And it may be way too big. Let's see what happens. So the faster moving objects now are, let's see here. Back to our screen space, back to that script. Let's make that a little bit more exaggerated. So the faster moving objects now have a bigger circle around them, which is kind of interesting. You can kind of think of that as a way of like looking at this data. And so you can get some nice looks here. The other thing we want to do is hide this maybe, this text shape. We don't need to show that now, so I'm going to go to the screen here. Since it's going to deactivate it anyways, I'm just going to move that to the top right corner so it's hidden now, so I just moved its thumbnail up there. And if we want this box here to be hidden as well, so we don't have this initial one, I can just deactivate it. But we also have to detach this because the emitter is going to emit this, and then it's going to call active. Since they share the same objects, the same properties, they'll both become active. So if I detach this and deactivate it, then the emitter will emit its own version that will be deactivated. So there we go. Another thing we could potentially do is filter out the really small ones because it's creating this very kind of dense. All the little ones are like overly, there's just too much stuff going on. So let's just look at just the big ones, not the really small ones. So back here in the stats manager, I'm going to look at the node, and we're only going to create it if the object has a certain radius. So I'm going to say if it's movable, if it has a rigid body and it exists, and the node's getBox, getRadius is greater than 0.2. So every object has a box, a bounding box, and we look at the radius of that box. And so only things that are bigger than 0.2, so that should filter out the really small objects. So now all these little ones are being filtered out, and we're just looking at the bigger ones. So it looks pretty nice, I think. We can make the ground maybe a little bit more visible here. So I'm going to go to the ground plane, and I'm going to go to its material, and maybe we'll give it a little bit of, it's white, it's just completely transparent here. So if I set it to 1 here and set it to be a little bit, just barely setting its color here. Let's make it less specular here. Less specular, and then give it a little bit of gray, and then we can bring the haze up a little bit to blend out the ground. So now we have like a visible ground here. The haze is pretty strong here, so maybe that's not what we want. Let's pause it. Let's take a look here. Reduce it. I don't know. I preferred it the other way. Let's set haze to 0. Let's go to our plane, our ground plane, the mirror, and let's just fade out the ground. Maybe just make it barely visible. That looks nice. So there you have it. We have this kind of neat way of visualizing something. Projecting is the crux of this example, and how do we do that? Again, in our two-dimensional object here, we wrote that code that has this project to screen, and we do that every frame basically, and we just connect an object in the space with this object, this 2D object, and we move it alongside with it to get that kind of effect. I hope this is interesting. Now I'm stopped, so it doesn't move. It only updates when we hit play, so that's why that doesn't happen. And then we have this kind of freeze frame kind of effect here. So I hope this is interesting. I will share this up on Steam so that you can open it and tinker it yourself. And thanks for joining us, and we'll catch you next time.